Hello all. Welcome back to the fifth session in this object-oriented programming techniques in JavaScript. So in this part, we'll be looking at object-oriented principles and how to achieve the same using whatever that we have learnt until the first four sessions. So firstly, to start on with, we will list out the principles of object-oriented technique in general and then try to address each of them using the concepts that we have already aware of in the first four sessions. Encapsulation, inheritance, dynamic method dispatching, open recursion, namespaces. These are the 5 concepts of object-oriented techniques that we can see on how to achieve using JavaScript. Just as a rewinder, encapsulation is nothing but the packing of data and functions into a single component. So the examples that we have seen throughout the first 4 sessions do cover the concept of encapsulation, wherein we encapsulate both the data and the methods themselves into prototypes, into objects. So that concept we should be already aware of. So in this case, I'm just taking an example. Object 1 is already having 2 properties, and there is a function which uses the same to display it. Whenever that function is invoked, you get an alert displaying the properties of the object. So this way we encapsulate the entire definition of an object within a block. Encapsulation. So we have already seen that the dot prototype convention of extending an object's functionality such that each individual object do not get those functions objects created specifically for them. Okay, so in encapsulation we have various types of access modifiers across the object-oriented programming languages, but in JavaScript there are only 2 types of scopes or access modifiers available: private and public. So we'll take this example. In this example, I have an object person which is pointing to a function object, and there are 2 parameters that it accepts. There are 2 variables that it is assigning to, and there is a function that I have defined which displays the 2 properties, and there is another function which is just a utility function just to compute the multiplication of the age factor, and then I make this function as a global function, which I'll be explaining on how to make the same. So first, let us understand that there are 2 keywords in JavaScript that are reserved for public and private. For private access modifier, you need to use the var keyword, and for the public it is this operator. So in this case, I instantiate an object of person and then call a function, display function, on the same. So it should now go to this display function, use the private member variables, name as it is declared as var, so it will be a private member variable, and then I try to access object1 dot name outside the definition of the class. Let's see whether it gives an error. Undefined. So you get an undefined value when you try to access the name property outside its definition, outside the prototype definition of the person. So now I change the scope of the name variable from var to this, making it public, and let us see whether it works this time when I try to access the same outside the scope of it. Now it gives me the value of the name, and when I try to access the second operator, second member variable of the person object, I'll get an undefined. So to make it as public, I'll just change it to this operator. Now you will see that there is an error. Why? The error is because inside compute age you are using age into 2. In this place you are trying to refer a public member variable without using this operator. This gives an error to you. So every time that you access a public member variable, you will have to use this operator before it. 9 years old, I think there is some error in it. So this operator is something that we will have to use in whenever we try to access a public member variable, whereas a private member variable should not be used with this operator. So the same thing when I use a var operator and try to execute the display function, which is referring to the name property using this operator. Let us see what happens. It gives you an undefined, is 20 years old. So public member variables have to be accessed every time through this operator, and the private member variables have to be accessed as is. this operator is used for the public access modifier. Okay, that is about encapsulation. Now coming to inheritance. Inheritance, we have understood two approaches of instantiating objects. One is a classical model and one is a prototypal model. We will try to address inheritance through both the approaches, classical model as well as the prototypal model. And to add on to this, JavaScript do not have a mechanism to call a super constructor or a super method, unlike Java, which allows you to do the same. So let us see the examples on prototypal inheritance and the classical inheritance. So in this case, the first example that I take is of the classical inheritance. I have a function which in this role is playing a role of a constructor. I extend it in this line and I instantiate an object out of it. So let us see some of the operators that we are already aware on this object. So let me comment out this line too. It gives me a true, and let me again call the instance of operator for the object class, for the object, that again gives me true. So this life answer becomes the first object, first level of object for my answer constructor, using the answer constructor and using the new operator. And in this case my desert answer also happens to be the immediate object of the answer. Then I instantiate subclass answer to firm answer. Firm answer becomes the subclass of answer. Let me explain you how. So this is the first line that you will have to have after the definition of the function, and the second line probably is this line. You don't need this. Okay. So let me see. In this case I define a function which is making a call to its superclass answer dot call. As previously discussed, JavaScript do not have the scope or do not provide a super operator to invoke the superclasses functions or constructors. It can use an operator called call, which is provided by the object, the super object of all our objects. So in this case, what answer.call this comma value does is it invokes the answer function, and it sets the current object which has invoked the firm answer, which is available in this operator. And when you call the call function on answer, this operator becomes the receiver of the call for the constructor defined above, and the values ends passed in it. So in this way, the receiver of the caller to firm answer is added on with the property underscore val with the passed value. This is the definition of the function. And now is the trickiest part. I do firm answer dot prototype is equal to object dot create of answer dot prototype. What it means is I am creating an object of answer dot prototype and assigning it to firm answer dot prototype. Now before this, let me first alert what is the value of firm answer dot prototype. Let me comment out the other lines. This happens to be an object, and the proto property of it points to the function or object. Because firm answer is still an object which is pointing to object dot prototype. You would see that the firm answer is constructed happens to be a function, and its proto variable points to the object dot prototype. So now that I would have to make firm answer as a subclass of answers, so I should create an instance of firm answer dot prototype which should be equal to object dot create of answer dot prototype. So when I alert for this, after instantiating, after making firm answer as a subclass of answer, it should no more be equal. It should no more be a true case. It has to result in false, because now the firm answer is not an immediate descendant of object. Firm answer becomes an immediate descendant of answer, and answer is the immediate descendant of object. It becomes a true object. Now after this, if you alert for the constructor of firm answer, it will alert me answer, which is nothing but this constructor. This should not be the case. For me, firmAnswer.prototype.constructor should give me the constructor for the firmAnswer, which will take care of invoking the answers constructor in it through a call to call. So I need this assignment of firmAnswer.prototype.constructor is equal to firmAnswer. So in this way, whenever I instantiate any objects of the firmAnswer, it will use the constructor provided in the firmAnswer, and it will take care of instantiating and invoking the answer as part of it, as part of constructing the object. So now these things have been covered. Now let me add on a method to this firmAnswer. I am extending the prototype of the firmAnswer by adding a new method to it, and it makes a super call to answers definition of get method by invoking it through answer.prototype.get.call. Now in this case, you will have to take this part of the expression as the complete method that is getting invoked, and when you call on that expression, it will invoke the method with this operator in here being set to the passed parameter, and the overridden definition of get method in firmAnswer appends two exclamation operators to the value returned from the answer is called to get. So this way I am overriding the function definition of the answer object. So now I go ahead and instantiate an object of firmAnswer, which happens to be lucky answer, and I have a variable passed to it 42, and let me now explain the way the firmAnswer constructor would work. On call to firmAnswer, it comes over here, and this invokes answer.call, passing this operator, the receiver of the call, and the value, the 42 in this case, to be passed in. So on call of this constructor, your answer constructor gets invoked, and its property underscore val gets a value of 42. This way I am instantiating the object of lucky answer to 42, and then when I alert for the value, as it is a public, in this case you will see that A is not defined, so ideally I should get an undefined value. Let me check. So it gives me an undefined value. Instead of .a, I'll access underscore value, and it should give me the value of 42. Okay, so that happens to be the classical way of establishing inheritance across objects, in which we majorly concentrate on calling the superclasses function through the call operator, and then instantiating objects through the new operator. These are some of the highlights of the classical model. So now let us go to the prototypal model of it. So unlike the classical model, in which we use the functions as the base templates for the custom objects that we'll be creating, in prototypal inheritance we'll be using objects by themselves as templates for other objects. So in this case I have an answer prototype. Observe the operators that are getting used here are colons, whereas in a classical inheritance it will be equal operators. And then we have the definitions and the member variables being separated by a comma operator. Now this happens to be the life answer happens to be the immediate instance of answer prototype. And when I call the life answer.constructor, it should give me this method, the definition of this method. So let me comment out the other lines. It gives me the definition of this function. So this way life answer becomes an immediate object of answer prototype. The prototypal, when I do an object.keys of answer prototype, I'll be getting the definitions of the two functions, the names of the two functions, which happens to be the member variables of answer prototype. And then I call my life answer.constructor passing a parameter of 42. And in this case, observe that unlike the classical way of inheritance, wherein the constructor takes the parameter, we'll have to make an explicit call to the constructor in the prototypal inheritance, passing it a parameter, and the constructor function takes care of initializing the member variables required for the new object that we are creating. So as 42 was the value, we get a value of 42. So now, one more difference that I would like to highlight is, when we alerted for object.keys of answer prototype, we got two methods, two definitions of the methods. And when I'm trying to alert the object.keys of the life answer, I should not get anything, which is not the case with the classical inheritance, because the classical inheritance makes all the member variables that are specified within the definition of the prototype to be newly allocated for each and individual objects. Whereas in the case of the prototypal inheritance, only the constructor will continue to have the properties. The individual objects do not have it. So in this case, I get an empty string for object.keys of life answer. So now again I instantiate an object, desert answer, very similar to life answer. Okay, now I go ahead and subclass my answer prototype to firm answer prototype, and in this case firm answer prototype just happens to be another object of answer prototype object, and then I extend the prototype of the firm answer prototype by giving a new definition to the get function. I'm basically overriding the get function as was done in the classical inheritance. I'm basically overriding the definition of get method from the answer prototype and providing it the same implementation as was done in the classical inheritance, wherein I just call the call method of the answer prototype and passing the this operator, and whenever I do a get on the object, on the immediate object of firm answer prototype, I should get the value that is returned from the answer prototype appended with 2 exclamations. So in this way I achieve inheritance. So now let me try to create an instance out of the firm answer prototype, and also call a constructor on it passing a value of 7. Let me comment out the other comment lines. After calling the constructor passing it a value of 7, I then call lucky answer.get to get the value of 7 appended with exclamations in here. So that was a missing alert that to be commented out. So the major difference, so now that we have seen both the ways of achieving inheritance in both the ways of instantiating objects, it's better to have a comparison between the two. In the classical inheritance, we use equals operator and each member variable separated by a semicolon, whereas in the prototypal inheritance we use a colon operator separated by commas for the member variables. And in prototypal inheritance, the complete structure will be built out of object.create for all the objects until the actual object, whereas in the classical inheritance majorly it will be new operator until we use a object.create for creating the subclasses prototype from the superclasses prototype. So everything else remains the same. Okay, so in this case already we have covered the dynamic dispatching, dynamic method dispatching. We understood the way method call happens. Let us take an example of get method, in this case lucky answer. So the lucky answers get definition is overridden a definition from the firm answer type, which has been inherited from the answer prototype. So the answer prototype just returns the value, whereas the firm answer prototype appends 2 exclamation operators to it, and the return value that you hence get is the overridden definition of the answer prototype. answer prototypes get method. So overriding is allowed in JavaScript, whereas overloading is not allowed in JavaScript. Why method overloading is not supported in JavaScript is, imagine you have a method defined at the super object level, and the same method you have at the subclasses level with a different set of parameters. And when you make a call, irrespective of the number of arguments or the type of arguments that you pass into the function, it will be the subclasses function that will be invoked. This is the default behavior of JavaScript. Open recursion is just a simple concept of referring to the objects inside the function of the prototype through this operator. So in this case, you will see when lucky answer.get is getting invoked, you will see that this operator is getting set to the receiver of the call, and in this case the receiver of the call happens to be lucky answer. So this operator becomes equal to lucky answer. And when you call answer prototype.get.call of this plus 2 exclamation operators, that is when a call function is invoked, it comes over here on a get method, it comes over here again with this operator pointing to the receiver of the call. The call takes care, call from the object takes care of setting the parameter, whatever the parameter that is set, to be equal to this operator and the superclasses get definition of the method. Namespaces in JavaScript. So now we have covered the inheritance, the dynamic method dispatching, and of course the encapsulation concepts of object-oriented programming. Now we'll go ahead and describe namespaces. Namespaces, again, it is nothing but the same as just another definition or another name that we have given to it. Answer prototype now happens to be an encapsulator for these two methods. If you consider it as something that is out of object-oriented programming techniques, then answer prototype becomes the namespace, and you have two other names that are defined inside that answer prototype namespace. So I can invoke the answer prototype constructor directly. This gives me a value of undefined, as my constructor function do not return anything. So let me pass a value to it, and then again call the get method on it. So this time it would return me a value of 15, which means to say that answer prototype becomes the namespace and constructor and get. So and in this way you can define multiple namespaces in your JavaScript to avoid collisions. So the types of namespaces are the custom namespaces that we define and the browser object model. The first thing is the browser object model and the custom namespaces. BOM, the browser object model, is provided by all the browsers. This covers objects like the window objects or ST objects or navigator objects. All these which are with respect to the browser comes under the browser object model, and namespaces that are defined by us comes under the custom namespaces. So in this case, though answer prototype is a namespace, it still comes under the global namespace of window. Window happens to be the global namespace for all the namespaces. So window dot answer prototype happens to be the one to refer to the answer prototype. So using this again, we can make a call to the get method. So that happens to be the same. The browser object model and a document object model. You have two different things in this context. The browser object model is the super parent of all the objects that have been declared in JavaScript, whereas document object model specifically refers to the HTML components of your page. So document is an object under window. And it refers to the complete HTML document, and using document you can refer to all its inner variables like the forms, the input fields and other things. The browser, the BOM consists of the objects, navigator, history, screen, location and document, which are children of the window. And the document is the DOM, document object model, which represents the contents of the page. You can manipulate it using JavaScript. We have already seen the custom namespaces. Okay, so now that we have understood the two ways of instantiating objects in JavaScript, we'll now go ahead and look at which is the best approach to create classes in JavaScript. So let us take an example of this. So in this example you will see that I don't need this code. Okay, I have a person. Before choosing the best way to create the classes, we'll have a look at why we are going for a best approach. And in this case, you will see that though the firm answer has been defined in here in the classical inheritance way of instantiating objects, you will extend its method definitions through a separate form.answer.prototype.individual method. So you're basically defining the functions or custom functions outside the definition of the class itself, outside the definition of the prototype itself. So this does not hold good when you compare to other object-oriented programming languages which have all the definitions of the methods and their corresponding variables in a single place. So in this case, I have an approach wherein we have a class person, and it is pointing to this definition. So let us go at it one by one. This piece of the code becomes a function. It declares a private member variable CT, and then it declares a private member variable __ construct, which is the initializer, and then I provide then I extend the construct prototypes with two new methods, greet and get count of instances, and this function returns me the construct. So what I get out of this entire expression is a complete definition is a function object which has the complete definition of the class embedded within it, including the new methods, the greet, the first thing being the constructor itself, and second thing being the two new methods that we have, the greet and the get count of instances. This takes care of returning that. Now when you make a call on that function using the parenthesis here, you get the actual function object. You get the actual function object, and you instantiate the variable class person to point to that function object. Okay, so now when I instantiate a object out of this object, then I can go ahead and invoke any of the methods that are provided by them. So this way I encapsulate the entire definition of my class in a single place. So this happens to be the best way of instantiating creating the objects in JavaScript, which uses the first class functions concept, wherein what you return from this itself is an object, and then you use that returned object and invoke on it to get the actual constructor object, and then use the same for all the new objects that we'll be creating. So now let us look at the recommendations for object-oriented JavaScript. Use the classical model happens to be the best model for the object-oriented JavaScript. Use strict. Now this happens to be okay. This being a normal code which will execute on a given instance, this alerts me 1, 2, 3 and 4. Now on the usage of useStrict, you will see that only one alert comes. The reason for this is useStrict is a strict mode of programming in JavaScript, which allows, one of the aspects that it covers is it doesn't allow you to use a variable without declaration. In this case, you will see X being used without being declared. So if I want to resolve the same, I can declare it as var X, and still 1, 2, 3, 4 comes. So this is a better approach when you're coding in JavaScript to follow conventions in JavaScript. Use JS hint or JS length. These are two coding check styles for JavaScript, very similar to what we have in Java for coding check styles. So this is an external tool that we can use to check and verify whether our JavaScript is following the right pattern of coding. It also checks the compilation time errors of JavaScript. the parsing time errors. So in this case, I take an example of a JavaScript file. So I have a simple variable which is assigned a string and 3.14, and with Notepad++ we can add in a plugin for the JSLint. JSLint, the current version is a combination of both JSLint and JSHint. So when I run JSLint current file, it is going to give me an error stating that AR was used before it was defined, expected an identifier. So this way we can resolve issues in JavaScript without even having to look at the code in depth. And as and when the class syntax is released from ES6, it is better to implement all our objects using the same. Advantages of object-oriented programming in JavaScript: makes code modular and easier to share, avoid value collisions in specific cases, makes specialized functions reusable. This approach seems to be a very good approach when on building web applications, enterprise web applications. It helps you to have a code which is modular and maintainable and also easier to share. And by establishing inheritance, it's a very good approach for you to maintain your code. The disadvantages of the object-oriented programming is, of course, the more number of lines that you will have to write. So in this session we have addressed how to achieve object-orientedness in JavaScript through the various approaches, and we have also seen the best way of doing or instantiating objects such that the definitions of the function remain in one place. In the upcoming session, we are going to go at we're going to look at which is the best application architecture suited for web applications of the current trend. Thank you.